Hi, my name is Jordan Schools, and I want to know, is a four-leaf clover really that lucky? When I started to determine what I wanted to do for my project, I thought about what I really liked or what would interest me. I thought about, well, I like farming because I grew up on a farm, and I also am in the fire department. Well, I was like, well, how can I relate these two together? Well, instead of doing farming, I went more with clover. My dad every year has to spray chemicals on his yard to get rid of clover, but it keeps coming back. So I want to see if by burning it with fire, the clover, will that help it not grow back? But I'm also going to test it with grass to see if the grass will grow back quicker, to see if that will help it. But I'm also going to look at if it will change the nutrients in the soil. Will it help it, the fire help it, or will it not really help it at all? I also want to thank Mr. Dutton for getting me through this and through this project. I also want to thank my dad, my papa, and my mom for all helping me through it and help me set it up, and mostly for me to be at this point. I also want to thank you for coming today. So a little bit of background information about clover. Clover is also known as Trifolium stoloniferum. It is found mostly anywhere nowadays. If you go out in your yard, you might find clover, unless you're at my house, and you aren't going to find clover at this point because it's all dead. But when in the springtime comes in summer, you will find clover in your yard. It is very hard to get rid of. Just like I was saying, my dad struggles every year to get rid of it. He has to spray chemicals, a high chemical on it, but somehow it keeps coming back after a while. But back in the 1940s, clover started to become an endangered species. But how can it become an endangered species if it's everywhere? They went through this process where it was hard to find, and that they thought that maybe it was a reproduction problem, or the animals that help reproduce it or pollinate it, that they weren't actually doing what they were supposed to be, or it was just not even working at all. They don't really know. But about 10 years ago, back in West Virginia, that's when they started to see more and more of the clover started growing back, and now it's starting to spread. It likes to grow in rich soils, and you'll really find it in open areas or prairies or places that you might keep cattle or horses or stuff for grazing for the animals. A little bit of background information about grass. It's also known as Poa annua, and this is your average type of grass that you will find outside in your yard. This is the type of grass that I use for my experiments, so it's mostly kind of the same type of grass. It can hold a heat stress from rapid temperature changes up to 40 degrees Celsius, which is around 104 degrees Fahrenheit. I looked at especially at the heat stress to see and how much it could tolerate towards the soil, because I wanted to see if this would help, if the grass could tolerate this heat, will this help this grow in place of the clover, so the clover won't grow back as strong, or not at all. As you know, it will need sunlight for seed germination, and it also needs the sun for photosynthesis. It can also tolerate poor soil aeration and low soil oxygen levels, so this could actually help for when I burned with the fire. Also, it can have a low nitrogen level, so if the fire gave it a low nitrogen level, but it might have boosted something else in the nutrients, this could also help it grow, unlike the clover. It can stay in harsh conditions to the soil, like burning to certain parts, and also when humans destroy it a little bit or something like that, they can stand it to a certain condition. Also, just like clover, animals help reproduce and increase the population. They eat it, just like going out here and eating the grass. They take it in, consume it, digest, and they let it out as waste. Then the waste will the seed will go down in the ground, and that's how it helps reproduce. Just like the same thing for clover. It's also self-compatible, which means that it can't self-pollinate itself, that it has to rely on others to do that for them. So my real question is, by burning clover for different amounts of times, does it affect the growth of clover and the change in nutrients in the soil? So my methods is, what I did at first was I took soil samples to determine the change in nutrients. I took soil samples before I burned the plots and afterwards. And then sent my soil samples off to southern states. I had 6 area plots. I had 3 plots for my clover and 3 plots with grass. So I could experiment on them equally. I had the area plots were burned for 0, 2, and 6 minutes. You might think, well, why is 2, why not 3? But when I was doing my experiment, when I first started off, 2 minutes it started to burn out on one of my plots. So I had a limited number of clover plots, so I had to just stick with 2 minutes for the rest of them. I took observations every week to count the number of plants of the clover and the grass to see how much had grown back. And also, I planted grass seed after I burned them to see if this would help the grass to grow back more, and would this help fight the clover not to come back. This is a diagram of what it kind of looked like. It wasn't this close together, but this is kind of what it looked like. The lime green on top represents the clover, and on the bottom the dark green represents the grass. In each plot it shows how long it was burned. Just like for plots 1 and 2, it wasn't burned at all. But for 3 and 4, it was burned for 2 minutes, and the plots 5 and 6 were burned for 6 minutes. My hypotheses for the growth, the amount of time that the plots were burned, was my null hypothesis was the growth that was burned for 0 minutes will be equal to the growth for 6 minutes. But my alternative hypothesis is the growth at 0 minutes will be less than the growth at 6 minutes. My other hypothesis for the change in nutrients was that for the soil there would be no change, which would equal to the soil will have greater than the 2% change in the soil. And my alternative hypothesis is the soil will have no change, which will be less than the soil with having greater than 2% change in nutrients. This is my first graph, which it shows the effect of the amount of time burned on the growth of grass. In this one it shows on the x-axis the amount of time burned in minutes, and on the y-axis shows the average number of grass plants grown back. As you can see, at 0 minutes you had a lot, but as you increase to 6 minutes, not many grew back, but some did grow back at 6 minutes. I had a p-value of 0.101, which is not significant, so I failed to reject my null hypothesis. This is the effect of the average change in nutrients on the amount of time burned for the grass. So this was the change in nutrients for the soil when burned for grass. On the bottom is, on the y-axis, is still the minutes burned, and on the y-axis shows the change in nutrients in the soil. As you can see in the graph, as time increased up to 6 minutes, so did the change in nutrients. So there was more nutrients in the soil after it was burned. I have a p-value of 0.312, which is not significant, so I failed to reject my null hypothesis. This is the effect of the amount of time burned on the growth of clover. On the x-axis you have the amount of time burned in minutes, and on the y-axis you have the average number of clover grown back over a period of time. As you can see, as you got to 6 minutes, no clover was grown back, which is good. So I came up with a p-value of 0.353, which is not significant, but I also have to fail to reject my null hypothesis. This is the effect of the average change in nutrients on the amount of time burned for the clover. So also I have on the x-axis I have the amount of time burnt, and on the y-axis I have the average change in nutrients. And as you can see, as the time increased, so did the nutrients. So this one really did look good. As time started to increase, there was a lot more nutrients being added to the soil. I had a p-value of 0.2985, which is not significant, so I failed to reject my null hypothesis. This is showing the effect of the amount of time burned on the amount of grass seeds growing back on the grass and on the clover area plots. As you can see, as time increased, the more grass seeds for the clover plots grew back more, but as for the grass plots, it started to decrease as the time got better. I came up with a p-value of 0.01065, which is significant, and I reject my null hypothesis. This is the effect of the average change in nutrients on the amount of time burned on grass seeds grown on grass and clover plots. As you can see, as it got increased, the amount of time burned increased, so did the change in nutrients for the grass seeds. I came up with a p-value of 0.000134, which is significant, so I reject my null hypothesis. So my results, the clover had a hard time growing back when burned for more minutes, but the grass did start to grow back more. So this could help the clover not grow back. The grass mostly had the same results as the clover, especially for the change in nutrients. As the time increased, so did the nutrients in the soil. The amount of time burned did affect the number of grass seeds grown back, because as the time increased, depending on the clover, it did help, but for the grass it did not. In this area plot, on the right side, this one just had grass in it. Which was only burned for 2 minutes. It consisted of all grass, but if you see on the right, a lot of the grass started to grow back. In this one, it was all clover. It was only burned for 2 minutes. As you can see, at the bottom and around the sides, clover started to grow back. In this one, it was all clover, but it was burned for 6 minutes. Nothing grew back except for the grass seeds started to grow back where it was replanted. So what I leave for you today is, if you do not want clover, burn your yard more.